Well, good afternoon. Welcome to Comp 620 and Comp 422. I just might point out that the cartoonist Tim Ricard is a nationally syndicated cartoonist. He lives here in Greensboro. That's Rooster Rocket Cartoons. Okay, we're going to talk about cookies and the domain object model. A couple announcements. Yes, there's an assignment due tomorrow at noon. That's you have to use SQL injection for the first two questions. I strongly recommend you look at the slides on SQL injection if you haven't already looked at that and got it. For the first two questions, you have to upload the answers. Oh, first two questions, sorry, you don't have to do it. It's automatically noted in the server. You make sure you use your correct ID number. And then for the last two questions, questions 3 and 4, you will have to upload something to the Blackboard. And it'll appear in Blackboard as two different parts, which I'll then add together later. Okay. There's another assignment, just to keep you from getting bored. There's another assignment out there. This time you have to do the number-based conversion thing again, but this time you need to cheat. You need to get a score of over 100, which the program in the browser tries to prevent you from doing, but don't let that stop you. There are ways you can do this. You might want to think about using the browser debugger or HTTP proxy. I'll talk a little bit about that today. And sometimes, depending on how you do the problem, the score that it shows at the end when you have to answer 20 questions may not show your enhanced score. But if you go out to the Get My Score thing, you can see all the scores you've had so far, and including if you see one over 100, then you got it. Okay. And I will know that you got it if you used your last 4 digits, your ID number as your user ID, and if you got the score correct. It stores on the server. I'll just copy it off the server. Schedule coming up here. Today we're talking about cookies. On Tuesday, it's not shown. Tuesday, of course, is that assignment due at noon. Wednesday, we'll talk about cross-site request forgeries, and we'll do a review for the exam, which is on Monday. On Sunday, the other assignment is due. And Wednesday, moving on to something else. Important point here is on Monday. Oops, sorry, that kind of Monday. Is the last day to drop. It's also no class. It's a week from Monday. It's fall break. There's no classes. It's also the last day to drop. So if you really mess up on the exam and you think you're doomed, then you may want to drop the class. Your last chance to do that is Monday at 5 o'clock. So don't miss the deadline if you want to do that. You can do that Monday at 5. At Tuesday morning at 8, it's much, much more difficult. Okay. And it's halfway between beginning of the semester and November 18th and 20th. So I just thought I'd remind you that classes will be online only. For those of you who only watch it online with Zoom or watch the recordings on YouTube, you won't even notice it. But if you happen to be sitting here in Graham 208, then be careful. Be remembered that on November 18th and 20th, a month and a half away, it's going to be online only. And we'll have a guest speaker on one of those days, on the 20th, I think. Our Google guest professor, visiting professor, will talk about web security, talk about security on the cloud. All right. Today's topic is cookies, HTTP cookies. Okay, cookie is just a bit of information that is sent along with the page that you're looking at. You don't see the cookies in the browser. They are sent in addition to the information. They're sent in the header, the HTTP header. It's just an option that's going along with the HTTP header. It allows the browser and the server to send information to keep things in sync. Basically, here's how it works. You send something, your browser sends a request to the web page. So you're going to go to the web page the first time. You send a request to get the page. The browser replies with the page that you want. And in the options in the HTTP, it puts some cookie information. It's just cookie, colon, and then whatever you want to put until new line. And now every time your browser goes out to that website, it should send that cookie information. Uh, Browsers are programs that start every time you go out to the web page. Not like you write a program that you run on your desktop. You type in some input, then it goes ask another question, it goes to something else. That's stateful. Your browser starts the program every time you log in or every time you go and get a page. The only way it knows where you've been is by the cookies, by information that you send along with the request for the page. So that way you can keep track of what's going on. If you need to go to the next page or the next page, if you've logged in, that's usually recorded in the cookie. That way, if you go to a page and you haven't logged in, the system knows you haven't logged in. And they have all sorts of information in there. Typically, a cookie just contains a number, a sort of random hexadecimal number that it then uses to look up your information in its database. So it goes, oh, that's you. It knows that you are coming back and anything it needs to know about you. Cookies can contain all sorts of information, often username, what pages you visited, what you've done, sometimes all sorts of other form data, including like credit card numbers, geographical information. I happen to observed looking at the cookies that Wikipedia knows I live in Greensboro. In fact, more than that, it's got the latitude and longitude of where I live. It's a little bit off. The 36 parallel runs through my backyard and it has me at 36.06. So that's a couple miles north of me, but it has lots of information. There are two flavors of cookies. There are session cookies and persistent cookies. A session cookie is temporary. It lasts only for that session. When you go out to that website, it sends a cookie to the browser, and your cookie uses that until you stop using that web, until you terminate the connection with that website, and then it goes away. The cookies do not have an expiration date because they expire as soon as you close the connection. In some sense, they may be safer because there's no information that saves on the server between connections. So you send a request to get a page from the server sends you a cookie, you keep sending that cookie back to the server whenever you go back. And then when you're done, when you close your browser, that cookie just disappears. Persistent cookies, on the other hand, last. They have a expiration date. These cookies are stored as files in your system. And so if you go out to the website, again, let's see, the next day you're going out to a website you visited yesterday or last week, it will look and find the cookies and it will send that to the web server when you first go to that web server. There are several ways to specify the how long it's supposed to say. Anything that's not going to delete immediately. If it has any kind of date or time on it, then it's a persistent cookie. Two ways to do that mostly are max age. You can specify the number of seconds until this cookie expires, or you can give it a date, expiration date. Here's an example of a cookie. And again, you see this is just part of the HTTP header. It starts with set cookie, and then it tells me a bunch of information. It says it expires on this day. It also tells me the max age. I have noted that frequently they do both. Most of the time, the max age, 36 months, gives you this date. Although sometimes we're a little bit out of sync. Anyway, when that comes up, there are other options you notice. Path is / HTTP only secure, domain. This is other information that appears in the cookies. So, we have our first question of the day. So let's start that maybe. Maybe if, where, oh, there we go. Okay. There we are. Oh, anybody here in the room need a card? Okay. Oh, B is a very popular here in class. It's also popular online, although some people have some other ideas. Okay, the answer I was looking for was B, base 64 decoded. Okay, why that answer? Uh, First of all, AES decrypted. Well, you'd have to know the key, and we're not going to tell you the key. Converted to hexadecimal. Hexadecimal has the numerical digits and the letters from A to F. This has got V's and G's and other letters, so that's not hexadecimal. Yes, when you see something that's a mixture of upper and lowercase letters and numbers, it's usually base 64 encoded. They might also have, I think, a slash, maybe a dash. I think that's the other two characters. But yes, it's base 64. Okay. All right. There are options in cookies. I think I should point out a few. There are secure. Secure cookie can only be transmitted over HTTPS. Most websites these days use HTTPS. I mean, a decade ago, a lot of websites just use HTTP, but since then, everybody's gotten secure, and most websites use HTTPS. So, but that says if it's not HTTPS, you won't send the cookie. HTTP only says this cookie cannot be viewed from JavaScript. The browser program cannot see the cookie. The cookie, well, cookie goes back and forth. It can send the cookie and receive the cookie, but it's not allowed to look at it. In particular, it's not allowed to be accessed by the JavaScript program. Yes, we'll talk about it in a minute, but JavaScript program can access the cookie, unless you say it can. The path specifies where this cookie is supposed to be stored. I've noticed it's often set to / or the root for that site. You do that unless you have some special cookie. And then domain. Domain indicates that this cookie not only works with this one website you went to, but it works for all web pages in this domain. So your domain might be like ncat.edu, or in the previous example, it was insomnia.com, insomniacookies.com. Okay. More options, same site. This cookie is used to avoid cross-site request forgeries, which we'll talk about on Wednesday, along with a review. And there are options. You can go cross-site request forgeries, specify that it's strict. And if it's strict, then this cookie is only sent to the same site that gave you the cookie. If it's lax, then you got this cookie and you may send it to other sites. And we'll talk about that. And none just lets you send it anywhere you want to, which is probably not a good idea. Okay, you can basically refer to first-party cookies and third-party cookies. First-party cookies come from the website where you went. That's the website and the address bar. When you type in www.acme.com, the first-party cookie comes from acme.com. Or if you click on a link to get there, but it's cookie that comes from the website where you're going to. A third-party cookie comes from a different site. Your web page may load lots of files to display on the website. A lot of web pages have all sorts of files they download. In addition to images that they display, they might download information, JavaScript files. They may download also tracking information, because all of those are third-party cookies. For example, let's say you go to acme.com and it has ads from adguy.com. There are ad brokers out there that sell these. We'll talk about how these work a little later on. But basically, you've got ad guys. So if you go, your web page at acme.com sends requests to adguys.com to get files that you're going to display. And it sends the cookies when it does that. Then if you go to another website, say other.com, and it also goes to adguys.com, it sends the cookies. And now the adguys.com know that you've gone to Acme, and it knows that you've gone to other.com. And they can send appropriate things. Here's a web page of my wife that has all sorts of advertisements. You got advertisements here, there on the top, all sorts of links to social networks. when you go to this web page goes to advertisement brokers that provide all these advertisements to display on the page. In other words, whoever made this page didn't say, I want this advertisement. They just said, I'm going to show an advertisement from this ad broker, and I'll put it here, another one, I'll put it there. If you click on these ads, it sends you to that website along with information that you got it from here. And usually there's some financial incentive for a web page to direct you to these vendors, so that you want your web page to send people all over because you get money for it. I might note, let's see, where example here. Okay. Sometimes you go to certain companies, online merchants, particularly Amazon. I use Amazon, and they do this all the time. If you go there and you're browsing around and you look at widgets on the Amazon website, then if you go to another web page, just something completely unrelated, you get advertisements for widgets along the side. How do they know you wanted widgets? Because Amazon tells the advertisement brokers, people are looking for widgets. If you see this person come by, again, send them an ad for widgets. I know they want to buy a widget. What's annoying is if you already bought a widget from Amazon, it keeps telling the other people, send them more ads for widgets, which I no longer want because I bought all the widgets I want. And again, there are advertising brokers who sell this advertisement. So Amazon relates to them and tells them the information, and that so when you connect to that off acme.com sends the cookie, says, oh, that's me, and says, I know he wants widgets, and sends information about it back there. I might note that my wife and I used to share an account on Amazon. We both buy, since we pay for it the same way. We've got separate accounts now because you come around to Christmas and I looking up something on Amazon, and I think, yes, she's going to want this. Well, after that, she'd go to almost any website and it would have all sorts of advertisements for what I thought was a secret item I was going to buy her for Christmas. No more secrets. Amazon is telling her all the time, he's looking at this. So now we have separate accounts, so she doesn't know when I'm looking at something on Amazon. There are tracking cookies. Everybody wants to know what you're doing. There's a huge market out there to keep track of what people are doing on the web. Browsing habits. They want to know people who are doing. That way, they can target advertising at you. If you don't look at certain things, they won't send advertising information to you about that topic. They certainly know what party you've been looking at, if you look at that sort of stuff. And then the advertising people will send you information about those candidates and not the other candidates because they don't think you're interested. So the third-party cookies, again, they keep where you've been going, what sites you've been looking at, and whether you actually clicked on those sites. And of course, keep a history of when you did that sort of stuff. They keep also. Now, cookies do have a valid use, particularly in session management, trying to keep track of whether you've logged in, what you've looked at. Almost any site that requires you to log in before you use the site is going to send cookies so that they know that you've logged in. When you log in the first time, they then send a cookie to your site saying, yep, they're logged in now. And therefore, if you go to another web page, it knows that you are still logged in. And again, usually they just send a random string of letters and numbers that they make up, and they then send that off to you, and you send it back. You go, oh, I know who this user is. An easy way to make a random string of letters and numbers is to take your session ID. That is, when you go into PHP or whatever program on the server, you can say you want to create a session, very easy, and then it automatically creates a random number, sends it off in the cookies, and back again. And of course, the cookies also help personalize it. You go to the website, and after you log in, it comes back. hello, Ken, blah, blah, blah. It knows who I am because it knows who I was. The cookie's information goes back and forth and keeps that sort of information about it. You can keep all sorts of information. I have an example cookie that I got a couple of years ago from the North Carolina Digital Library. By the way, North Carolina Digital Library has all sorts of things. If you have a Kindle or some other reading device for reading books or sort of or novels or magazines, you don't have to buy those things. You can check them out of the North Carolina Digital Library. Go there and you can check these things out and you can get them downloaded to your Kindle. It works really well. And it's free, which is always a nice feature. Libraries are one of those great things humanity developed thousands of years ago, and we still got them. Look, this is a long cookie. It's got all sorts of information. It's got my email address in there. I think it's got my name. It's got where I am. And what I always like, it has checkout limits by media, and then has this. And it says ebooks. I can check out 6 ebooks, which makes me think, oh, if I wanted to check out more than 6 books, which I rarely do, can I up this number to 8 to 10 so I can check out more? Also, the limit, how long can you check out books? If I want to check it out for a couple months, can I update that number? Probably. That's why now I went out to the library and looked at the cookie. It's much shorter. It's just a number. I'm sure they keep all this information in their database, and now they just go out and look at that value. So you can't change it. Okay. Sometimes you might want to look at the cookies. Again, if the cookie is not HTTP only, then your browser can look at it. If you're in the browser, you can go into the debugger. Now, to get in the debugger on Chrome, you can go Control-Shift-I, I as in inspect, or you can right-click the page and go to inspect, or you can go up to the options and go to inspect. Some of these also work in Safari and other browsers you might use on different systems, particularly Macs. Go up into the options, go to inspect, and it starts the debugger. And in the debugger, you can look at the JavaScript variables, put a watch on them. The variable document.cookie, document being the object, at the document, of course, being the whole document. And cookie, you look at document.cookie, and you'll see the value for the cookie. And if you need to, you can copy that data, copy that and then paste it into Notepad or something so you can look at what it is. Oh, there's also a program called Curl, C-U-R-L. It runs on both Windows and Linux and Mac OS in your command line things. And you go curl space website. If your website uses HTTPS, you have to put the HTTPS. Otherwise, it defaults to using just HTTP. And most of the time, you'll just get back a message saying, this page has been permanently moved to another one, which, of course, is what your browser is seeing. And your browser then has to go to the one. It's of most interest if you use the -- verbose option. So you curl space -- verbose space HTTPS : / whatever your favorite website is, and it will show you that information. It also displays the whole web page, gory details, which may be more than you want to see. You can go in the option, go -- output, give it a file name, something .text, and all the text of the web page will go there, not display on the screen. So that's one way of seeing these things. Okay, I think I just mentioned document.cookie is where your browser keeps it. If it's not an HTTP only cookie, then the the JavaScript portion of the program has access to the cookie. It can access it along with the rest of the domain object model. And you can change it if you want to. Okay, there are some issues with cookies. Sometimes the cookie has all sorts of information about you that you could possibly change along the way. And that's probably not good for the way the program expected it to work. Also, the cookie identifies you. It says, actually, it doesn't identify you. It identifies the browser and the user ID. Oh, Here's a question. Let's try this one. Oh, something's upset. Hang on here. Now you should be able to see it. Okay. Got an idea for this. Okay, B and C are about equally popular. Oh, somebody just voted for B. Okay, we got 64% participating online. Get the results. Okay. Well, nobody said A, which is good because A is completely wrong. C, by right-clicking and selecting view cookies. No, I just made that up. I don't think that works. It seemed like a logical, and I just made it up as my. None of the above is incorrect because by using an HTTP proxy, and I'll just talk about HTTP proxies in a couple minutes and give an example, but that would be the correct answer. Okay. Because cookies can identify a person, they actually identify a user is signed on to this computer going to this website. It doesn't necessarily know it's you. It's just that your user ID is trying to log into the site. The General Data Protection Regulation of the European Union considers that personal information. And it has laws regarding the collection and dissemination of personal information. And so cookies are involved in that. So most websites that will appear possibly in Europe, and people who are trying to get a lot of business from anywhere in the world wants their website to operate in Europe without getting themselves into trouble. Nobody wants to have the European Union put out a arrest warrant for your website. So they follow the rules saying you have to agree. A few years ago, there was a big flurry of banners across the bottom of your page saying, this website uses cookies. Click here to agree or click here to specify what cookies you're going to allow. And that was primarily created by the GDPR regulations in the EU, that you have, in the EU, you must specify that you are allowing them to collect this information, or they can't collect the information. Yes, if you don't want the website to collect information, or you don't want the cookies, there's incognito mode in Chrome. It's in private mode in Microsoft Edge, and there's also private browsing mode in Safari. All of them have it, and they keep the system from storing information. They store it, but then when you close the browser or log out of the website, it erases all the cookies, all the history you store. Typically, when you use a browser, as you go to a web page, it stores that web page on the file system that you have, and then when you go to it again, it goes out and says, well, do I need to get this? I already have this stored in my file system. I can just copy it from there. It will delete all that information if you're using any one of these private browsing modes. Web beacons. I've been looking up web beacons. Web beacons are information. It's information stored on a website that sends data back to a web server to say that you have viewed this web page, or email. You can put them in email, you can put them in web pages. And just to make it easy so it always works, the World Wide Web Consortium has come up with the Beacon API. The Beacon API has a function that you can call in JavaScript or HTML5 that says, send this information to this web server, and make sure it's asynchronous, meaning it happens in the background while everything else is running, so it doesn't block your web page, and it will occur. Even if you close the web server, it makes sure it gets that's done before it quits. And again, this just sends whatever information the web page or the web or the email wants to send to whatever server it identifies. I kind of find that rather bothersome for privacy's sake. And as far as I can tell, there's nothing much you can do about it. There are a few third-party tools you can purchase that will help with your security and block web beacons. But the browsers themselves, you can't go out to Chrome or Safari and say, turn off web beacons. They don't do that. Probably because those people make a lot of money keeping track of where you're going. And there are other ways of keeping track of where you're going. Some, typically before they had the Web Beacon API, they would have a 1-pixel image out there. And your system would go out to a website to retrieve the 1-pixel image. Well, that 1-pixel image was usually a clear, a transparent 1 pixel. So it doesn't show up at all on the web page, but it does tell that site that, oh, look, you have gone out and grabbed this. So I know that you are reading this email or that you are looking at this web page. That's what it tells. And again, keeping track of people and selling their information is big business on the web. All right, I want to talk a little bit about the domain object model. This is a little bit about how HTML works. We don't expect you to be HTML programmers, but some of the things that happen as far as security do involve the domain object models. Just let me briefly go over how that works and how you might use it. Okay, it's a tree. This defines all the objects in a web page. Every element, every bunch of text, every input field, every button, every image is part of the document being the root of everything. And all of these are divided into paragraph divisions and stuff. And you can access all the different parts. It's object-oriented for those object-oriented programmer folks. So all these objects. Okay, so imagine for now that X is some sort of object. It could be a button, it could be an image, it could be an input field, it could be a paragraph, whatever it is. There are different things you can look at it. Inner HTML tells you the text of that. So if it's a paragraph, you can see, what does the text say? By the way, you can not only retrieve it, you can set this. Node name, what's the name of this node? What's the value? What is its parent? Because things have again, there's a hierarchy. Oops. You can go, oh, this is say a paragraph, and or this paragraph is inside this division. You can find out, whoops, got on the parent and what are the child nodes, what can go both ways, and attributes, what attributes is the system. So all sorts of things you can find out. Typical way you connect to a object on the web page is by putting an ID on the web. When you create the web page, if you want to specify a particular paragraph and be able to do something in that paragraph, you give it an ID. Here I call it the one. This is the one you want. So you put the ID. And then later in the JavaScript, you can later go get element by ID. It's document, get element by ID, and specify the name. So the name here is the ID. It's just getting ID. And that will return this object. This will return that paragraph object. And then you can do all sorts of things. That paragraph object, I called it my paragraph. Of course, it doesn't actually have to be a paragraph. It could be a picture or a button or whatever. You could, buttons, pictures, all those have IDs. You can put them. And then you can, in this case, we're just putting some new text. So while the web page originally said original message someplace on it, you can change that to something completely new. You can change the text of the web page in the JavaScript of that. You can change the style. You can change the attributes. You can style property. Normal, again, get it by ID. You can say the style is red. Click. You can change attributes. One of the attributes is, here, the source. In other words, we have the bracket image attribute specifies an ID and the source. The source is where is this image coming from? If you don't specify URL here, it assumes it's on the server where the page is located, and on that server in the same directory, there's a graphics called sad.gif, And now we're going to change that to happy.jpg. So you can change that, and that will change what image is displaying on your web page as determined by the JavaScript as it accesses the domain object model. We have looked a little bit at the alert JavaScript. The alert, I use alert all the time because it's safe. It doesn't break your system. And you can use this. You can specify parts of the domain object model here and do things with you. Not only display you can display document.cookie, and that will display your cookie, in case you want to display that. There are all sorts of events.
I might have to just get these things off to because what?
Excuse me, could you repeat the question? Hello? Yes? Somebody said something and I didn't quite hear it. Want to say it again or not? Okay, well, move along then. There are all sorts of events that occur during the execute of a web page. Obviously, when you click something, that's an event. You can just mouse over. If you mouse over a link, if you mouse over a picture, if you mouse over any element you want to capture. There's also when you first start, when the web page is loaded, when you enter the page, when you leave the page, when you change something, you can have on change is a action or an event that you can fire. Often you have an input field and you say on change, call this function. So if you change that function in any way, type something in, click on it, whatever, when you change it, it calls that function. Your JavaScript can do whatever it wants to that. So that brings us to another question here. Right. We got an idea how I might think about that? I didn't really say that, but I did say it in a roundabout way. Okay. Now look at it pops up and tells me your card. Sometimes it tells me a letter. It's practically what you're holding up. Somebody just got a letter G. Why are you giving G? There's only 4 letters to choose from. Okay, A was real popular. B and C. Okay. I didn't say this, but I did point out that there are events. One of the events is you just loaded this page. That's an event that can fire off an action in JavaScript. Therefore, you don't have to click on anything. Just being there starts the JavaScript program, and that could be an attack. Now, when I say attack, you could look at it from 2 points of view. One is you are attacking the web page. The other way is the web page is attacking you. You're not always sure that the web page is clean and wonderful and healthy. Some sites are out there to get you. They're out there to capture some information. And the JavaScript, which is the program in the HTML, it can start executing as soon as you get to the page. You don't have to click on anything. Just by getting there does it. We do this. Okay, moving on. Maybe. There we are. There are HTTP proxies. These are programs that allow you to look at all the HTTP traffic going to the server and back. There are a couple of very popular free ones. There is the ZAP one made by the OWASP, the Open Web something security project. Yes. And then there's the Burp Suite Community Edition. Makes the names. It has been my experience that the Burp Suite Community Edition is easier to use than the Zap proxy. And you can get information on it here. Let's give it a try. All right. Hang on, we're going to okay. Here we go. We're going to go out and open the Burp Suite program. I'm going to go to how about, okay, I'm try sharing this. Hopefully this works. Okay, when you open it up, first thing it tells you, oh, you got this old stuff. Do you want to delete it? Yes, you yes. Oh, darn. Why can't you see anything on? Excuse me? Oh, yes. Let me just, okay, but then I can't see it. All right, hang on. Let me delete this. Oh, okay. Let's give this a shot and see if this works. Yeah. Oh, okay. I believe the people online can still see this. Somebody want to verify that?
Yeah, I can see
Yeah,
it.
we can
Okay,
see.
great. Thank you very much. All right. And after that, then it comes up with this. The only option is temporary, unless, of course, you want to buy the professional option, pay money for it, which, that's your choice, but I'm not going to pay any money. We'll go to next. There. Okay. Start burp. All right. Clickety clack. It thinks about this for a couple seconds. It takes a little while for it to start up. No way, still. And okay, that went away. And my mouse, there's my, we'll have to try showing, okay, everything has gone away. We'll try to, whoop, that's not any good. Copy this over to the other screen. Hope this will work. Back to